Go ahead and get your the free response question that I passed out on Friday, and you guys kind of worked on it. We were just barely going over it. We covered part A, right, before we left? Am I right? Yes. Okay, so we got to get through B, C, and D. Like I said, this type of question pretty much always pops up. I'd say out of 7 years, 6 out of 7 years I see it. Okay? So it's always there. All right. So we did part A. We said, I even gave you the grading thing. So put a score on it as you go along to see how you did. And that's as far as some of you guys got, huh? Okay. That's okay. It's our first look at it. Part B. Part B. G is defined in part A. Find the x coordinates for each point of inflection. So, think of your chart. G has a point of inflection. When? What? When G double prime of x changes signs. Are you guys okay with that? That's old, right? Okay, now, did I give you G double prime on the graph? No, I didn't give you G. I gave you F. Well, if G is the integral of F, then G prime is what? G prime of x equals F of x. But I don't care about G prime, I care about G double prime in a sense. And we wrote this down the other day, but G double prime is equal to F prime. So here's the final answer that we're going to say. When does G double prime change signs? Thinking of your chart. When, I guess there's a couple ways. G double prime changes signs when G changes concavity, or when G prime changes direction. Okay, so let's do this. We were given F, right? So F is equal to G prime. So then we should try and translate this according to the graph that was given. So since G double prime changes signs, we are looking for when G prime of x, which equals F of x, changes direction. So when does that happen? When x equals 1, since you could say F changes from increasing to decreasing. Changes direction. Okay. So again, you want to relate the thing that it's asking about. So it's asking about G, so you relate it to G double prime, which is related to G prime, which is related to F. Does that make sense? I mean, you just got to be able to translate it. You go, okay, I want to know about G double prime. How does that relate to F? Well, G double prime is equal to F prime, so G double prime is related to G prime how? Okay. How do you grade it? Let's see. Part B, you get 2 points. 1 for identifying the x value, 1 point for the correct justification. And so you should have something like this maybe for justification. Are we okay with that? Who got that one right? Anybody? 1, 2, 3, 4, 5, 6. Okay. Okay. Part C, it says let h of x equal what? The integral from x to 3 of f of t dt. Now, we want to know when h of x equals 0, right? So we are looking for when 0 equals the integral from x to 3 of f of t dt. We know one obvious answer. What is it? When x equals 3. Because the integral from 3 to 3 is 0. The integral from, if the lower bound and the upper bound are the same, you get 0. But if we look at the graph, what we need to try and see is there anywhere else where the integral will produce a 0 value? What's another way that an integral can be 0? If the net area is 0. So if the area above the x-axis is the same as the area below the x-axis, right? Where is our region that we're trying to find the area of ending? It's from x to 3. So our lower bound is, we don't know, but our upper bound is 3. So we are trying to end here. So we're kind of going backwards because we're trying to find a point somewhere over here so that when I take the integral all the way to 3, it's 0. What if I took the integral from 2 to 3? That'd be what? Negative. So how far back do I have to go in order to cancel it out? To 1, because if you draw a line there, you end up with a triangle that's the same as that triangle, right? So those cancel out. So where else does it equal 0? When x equals 1. And then can I go any further back and still get zeros? Well, if I go from 1 back to 0, what's my integral from 0 to 3? Positive, because this region is more than this region, right? But if I go back further to -1, then this little triangle compensates for that little triangle that I just added. So that's also a 0. Does that make sense? And if I keep going back further, then I'm just making more negatives, right? So it's not 0. It didn't ask to. Oh, where did I get that from? -1. Okay. It didn't ask to justify, so that's good.
So is that just like spatial skills? Can you like recognize shapes?
Well, and it's trying to make the connection that what integral means. Yeah, kindergarten, you know. All right, so let's take a look at the score for that. This one's interesting. Everybody should have gotten 3 as an answer, right? Right? So here's how you grade this one. You get 2 points to start off, and you subtract 1 point for every one you didn't get. Right. So if you got the first one, you start off with 2 and you subtract 2 because you missed 2, so you get 0. So if you got one of them right, you didn't get any points. You had to at least get 2 right. Because that one was obvious. Oh, bummer. Okay, so if you got one of them, you got 0 points. If you got 2 of them, you got 1 point. If you got 3 of them, you got both points. Does that make sense? Okay. I'm sorry. Did you get the first one?
I didn't even get past A, bro.
Okay, bro. All right. D. For what value is h decreasing? So h is decreasing when h prime is negative. So we need to take h prime. But the problem is, how do we take h prime of a function with an integral? We should know this. Take the derivative, but I can't take the derivative necessarily easily when the variable's on the bottom. So let's flip it. So h of x is equal to the negative of the integral from 3 to x of f of t dt. You guys okay with this? Yeah? Now we'll take h prime. What is h prime? Negative f of x. Why? Because we plug in the x, and then we multiply it by the derivative, right? We're doing the chain rule. So times 1. So when is h decreasing? H is decreasing when what? Not f. H is decreasing when h is less than or equal to 0. When h is negative, right? No? Are you guys okay with that? Jenny, is that okay? Think of your chart. H is decreasing when h prime is negative.
H prime, you said H.
You said f. So we're both wrong.
Isn't H prime the same thing as F?
No. H prime is negative f. Because we had to put the negative up front. So we're both wrong, right? All right. Yeah, that's fine. Okay, so h is decreasing when h prime is negative. Well, when is h prime negative? Which would imply if h prime is negative, that means f is what? Positive. Yeah, because you can have a function that's doing this if you're going to say increasing. The slope is 0, but technically it should be including, but you don't have to worry about it. So h is decreasing when h prime is negative. That implies that f is positive because h prime is the opposite of f, right? So when is f, because now we're looking at the graph of f, when is that positive? Therefore, from 0 is less than x is less than or equal to 2. All right? Okay. Take a look at that scoring guideline.
Explain your reasoning.
So 1 point for the interval, 0 to 2. 1 point for the reasoning. So, yeah, you would have to say h is decreasing when h prime is negative, which implies f is positive. Okay? Yeah. The 2. This 2? This is the graph of f, right? You agree that we're looking for when f is greater than 0? Above the x-axis. Okay? So that's 2 points. If you look at these averages, the average on any FRQ can range, honestly, how much is it out of? Always. 9. I've seen averages as low as 1.5 on questions. That's global average. Well, yeah, over half the kids pass. Statistically, about 55% of kids globally pass the AP exam. So that tells you that you don't have to stress so much. You don't have to get a 9 on everything. Now, hopefully, we'll progress closer to that. But honestly, this one was probably an average of 3 to 4, somewhere in there, probably 3.5. So has anybody got 4 or higher on this, if you were to score it? 1, 2 people? That's it? 3 people? How about 3 or higher? Anybody get 3 or higher? Part A you guys should have had, right? Yeah, but. Okay. And so, granted, this is your first time. So when we go over more and more practice, you should see your average scores going up. So we know how to take an integral analytically at this point, right? You take the antiderivative, you plug in the upper and lower bound and subtract, right?
Yes.
Now we are going to take a step back, going back to approximations, and the reason that is the case, the reason we have to do that is because most data that we apply in real life is not given to us by nice, easy equation that we can take the antiderivative of. Most of it is data and tables. So we have to be able to approximate because that's the only data that we have. So let's do a quick review of rectangular approximations. Okay. Let's say I want a left-hand Riemann sum from 0 to 8 using 4 subintervals of that function. A left-hand Riemann sum to evaluate or to estimate the integral from 0 to 8 of f of x dx using 4 subintervals. How wide is each subinterval?
2.
From 0 to 8. So each subinterval is 2. But how do you determine the height of each subinterval? What? Okay. First of all, we do say that it's we have a vertical line every 2 units. And then if we're looking at it, am I going to use the height of the first f or the first x value or the second x value? For a left hand, I'm going to use the left hand point, right? So how high is that? 4. So how wide is it again? So we would say we have 2 times 4. And then for the second rectangle, how wide is it? 2. And how tall is it? 3. So it's 2 times 3. For the third rectangle, how wide is it? How wide is it? 2. How tall is it? 0. Okay. And then for the fourth subinterval, how wide is it? 2. And how tall is it? -1. Okay. Some of you might want to say, well, there's a triangle here. We're not looking for that. We're looking for the region that's bounded by the key is the x-axis. Right? And we determine the heights of the rectangles based on the curve. So we're looking for the region between the x-axis and the curve heights, not between the end of the rectangle and the curve. That doesn't make sense. So we can get that. That's 12. You guys do the right Riemann sum real fast. All right, so what is the... Looking at a right hand, I'm going to use the same graph, but I'm going to slice it same way, 4 vertical lines, because 4 subintervals. or 3 vertical lines in this case. We're doing a right Riemann sum, so what is the width of the first one? What is the height of the first one? Because we're looking at the right point. So 2 times 3 plus what? 2 times 0 plus 2 times negative 1 plus 2 times negative 3. Notice what's happening. So we can simplify that. We got negative 2, right? What is the difference between a left hand and a right hand? If I want a left hand, I'm ignoring which height? The last one, the right hand one. If I want a right hand, I'm ignoring the first one, the leftmost. Are you guys okay with that? Now, obviously that is a big gap in terms of the estimations. One is saying it should be positive 12. The other one is saying it should be negative 2. How do we get more of an exact approximation? The midpoint might be more beneficial. Taking the average of those might be beneficial. I would argue that the average be the midpoint? No. The average would be something, though. We can talk about that in a minute. You could slice it into more rectangles, and you'd be more accurate. You guys okay with that? So if we were to slice it into 8 rectangles, then the width would be 1. And we'd be more accurate, right? Okay? But there's another way. Are you ready? So trapezoidal approximations. If I'm looking at the integral from a to b of f of x dx, let's look at the same graph from 0 to 8. And we're going to slice it in the same 4 subregions. How do I get a trapezoid instead of a rectangle in the first region? So we're going to go from the y value of the first point to the y value of the second point and draw a line. Do you see the trapezoid? We're going to go from the height of the left point to the height of the right point and draw a line. And we're going to do the same thing and the same thing. So you can see when we find the area of these regions, it's way more accurate than rectangles. You guys get what I'm saying here? Okay. Now theoretically, if we could slice it into an infinite set of rectangles, it doesn't matter. But when we only have certain amounts of data, we don't want to necessarily use a right or left hand. We want to use a trapezoidal because it gives us the best out of those options. Now some of you are probably looking at that going, they're not all trapezoids. Some of them are triangles. Right? Did your geometry teacher ever make the connection that the area of a trapezoid is the same as the area of a triangle? So that's the area of a trapezoid, right? What is the area of a triangle? So 1/2 base times height. It's the same formula except what? We actually do have 2 bases. We can call this base 2. This is base 1. Just how big is it?
0.
Right? So the area of a trapezoid is the same as the area of a triangle. It's just that in a triangle, one of the bases is a nothing. Is a 0. Okay? You could do the same thing with a rectangle. Base 1 plus base 2, what is it? 1/2 b1 plus b2 times height. That's the area of a rectangle as well. Why? Because what are we really doing when we say 1/2 b1 plus b2? What are we finding? The average of the bases, right? What's the average of the bases if it's a rectangle? It's the same thing. So you could use the trapezoidal formula to find any area pretty much. It's just why would you? Because it's just more work. Okay? So don't stress out. If you're looking at a triangle, we're going to apply the trapezoidal formula. In this case, it's just one of the bases is 0. Okay? So let's take a look at this and evaluate this. How many pieces do I have? How many subintervals? 4. The area of the first subinterval would be 1/2 of, what's base 1? Remember the bases in this case are standing on end, right? 4. 1/2 4 plus 3 times what? 2. Plus, that's just the first rectangle. Plus 1/2 of, what's the second rectangle's height? Or sorry, trapezoid. 3. And then the second base is 0. And what's the width? 2. Plus 1/2 of What's the third trapezoid? 0 plus -1 times 2 plus 1/2 of -1 plus -3 times 2.
Do you expect this to put 0 plus?
Yes, I do.
Okay.
Okay? And you'll see why in a minute. Do you guys get the trapezoids, right? Now, when you've seen the approximations before and I give you a table, are the subintervals always of equal length? Sometimes they are, sometimes they aren't. So not always, right? So this next thing I'm going to show you doesn't always apply, but if the subintervals are exactly the same, this idea is actually very simple. Okay? Are the subintervals the same? Yes. So what could I do with all of these terms to simplify this? No, I don't want to cancel because I want to show you something else. Since they all have what in common? 1/2 and a 2. Now, granted, those reduce, but I'm not going to do that yet. 1/2, and then, so that's the 1/2 out of everything. No, I'm not going to do that yet. 4 plus 3 plus 3 plus 0 plus 0 plus -1 plus -1 plus what? -3. That's all of them, right? And then times 2. So there is your 1/2 on your trapezoid. Here's trapezoid 1's 2 bases. Trapezoid 2's 2 bases. Trapezoid 3's 2 bases. Trapezoid 4's 2 bases. Are you guys okay with that? And then this is your height, right? This only works when the subintervals are the same, right? But if they are, what are we noticing in all these cases?
Add them all together. Add them all together.
Oh, you go for the first
They all
one, you double
cancel.
it. You double
In the first one, you only use the height, the first height once, right? And then we use the second height twice. One for the first trapezoid, one for the second trapezoid. Then we use basically the second height of the second rectangle is the same as the first height of the second trapezoid, or the third trapezoid. Does that make sense? Okay? So you're going to use every height twice except for the first one and the last one. But you need to understand that this is one trapezoid, this is another one, this is another one, and this is another one. We're using the same number twice because the two bases of the first rectangle here are 4 and 3. The two bases of the second rectangle are 3 and 0. Look, I used the 3 twice. One for the first trapezoid, one for the second trapezoid. This 0 I used twice. One for this trapezoid, one for this trapezoid. So all the intermediate heights we're using twice. The first one and the last one we're not using twice. Does that make sense? Now, I do expect you when you're doing this to write it all out, and you can only simplify this when the subintervals are the same. Okay? So, trapezoidal approximation would be this, and then I showed you the shorter version of that, but you end up with 5. And obviously, this approximation is way more accurate than the ones we got before, right? You guys okay with that? Okay. You guys try this, huh? Use a left hand, a right hand, and a trapezoidal approximation to evaluate the integral. I believe it's x squared, from 1 to 2, using 4 subintervals. Okay. Yeah, guys, try and do this without a graph. Try and create a table instead. Okay, so as I'm walking around, I'm seeing you guys all do tables, which is good, but a lot of you are doing vertical tables. How often do you see that on the AP exam? You see the horizontal tables more often. And it's fine if you understand it. If you understand it either way, it's fine. It's just maybe a little easier to see it this way. So what is the first x value we're concerned with? 1. And the last one is 2, so how wide is each subinterval? 0.25, because the total width is 1, and we're going to divide that by 4. You guys okay with that? And then I'm going to use my calculator or not and just figure out what those values are. Calculator is probably a good idea. If I want a left-hand subinterval or left-hand approximation, how wide is the first rectangle? 0.25. How tall is the first rectangle? We're doing a left hand. 1. So it would be 0.25 times 1, right? Plus, how wide is the second one?
0.25.
Times,
1.5.
and so on. Which one am I going to ignore at the end? The 4, okay? You get that. Hold on. For a right hand, which one am I going to ignore? The 1, and I'm going to add in the 4, right? Hold on. For a trapezoidal, what's base 1 of the first trapezoid? 1. What's base 2? 1.562. What's the width or the height of the the height of the trapezoid? 0.25. Okay? So you should see each one repeat twice except for the first and last one. Okay? There.
I didn't get the last one.
Okay? The first one is an under approximation because the function's increasing. The right-hand approximation is an over approximation because it's increasing. And the trapezoidal approximation is based on concavity. The trapezoidal approximation is based on concavity. We will talk about that tomorrow, though.